new way of thinking about architecting our product, and hopefully will give us some new and better results. Boyan, it's all yours.
Okay, hi all. So, I have a presentation this time. I was thinking, I was working on this the past 2-3 days, part-time. Just to mention that this is not a workshop about CQRS and event sourcing patterns, but it's more of a CQRS and event sourcing usage in ArkCase Next. So this is also a proposal how we should use it. So it's not a final version and it's missing quite a few details. Anyway, let's start. Just for introduction, I will try to go faster because we don't have much time. The CQRS stands for Command Query Responsibility Segregation. This means that we just separate the command and query parts of the application, and we have different models to update information than the model we use to read information. The model to update information comes from commands, which could contain few properties, and then the model we use to read the information might contain quite a lot, or anyway, it's some kind of projection of the data that we will show to the user, perhaps. By separate models, here we most commonly mean different object models, probably running in different logical processes, perhaps in separate hardware. And this fits the microservice architecture, and that's why we try to pursue it. The basic crude model that we now have in the ArkCase application is this one. We have the UI. User makes a change in the UI. The change is forwarded to the model. The model executes some validation and logic and updates the data in the database. And when the UI needs some information, the model is read from the database and returned to the users. And as you can see, they have very similar or the same model is used. That's how we have it now. The CQRS model separates these two responsibilities. So when the user makes a change in the UI, it creates a command which has its own model. As I said, it can have few properties only. This will execute some validations and logic, and the command will update the database. Can you hear me? I heard something.
Yes.
Yep, I can hear you.
Yeah.
I heard someone disconnecting. I thought it might be me.
All good.
Yeah. And when the UI requests some data, the data reads the data from the database or the repository it has, and we have a query model which returns to the UI. And these two models are different here. That's the main separation. In this presentation forward, I won't talk about the query model much. In our case, because the query model is yet to be discussed, we have some search service that we want to implement, so I won't go into details about query model. What I was thinking more is about the command model and how the UI interacts with the backend, and that is the main goal of this. A few more things about commands. the commands and events form a language for your application, and we need to make sure that we have a good naming of the commands, because they should reflect the business domain and not the technical domain. Commands are in imperative tense, so it's like create order or create case in our case, and events that are generated are in past tense, okay? Order created or case created, etc. The important aspect of naming a command, as I said, is to make sure that they reflect the business domain more than the technical domain. So we should think about this. For example, when we change an address to some person, let's say, do we have a change address command? Is this, or we should have two separate commands, like correct an address and another one like relocating the person. The person has relocated, he's using a new address. So these two are different, and we need to think about when naming the commands and creating them, of course. We have a few warnings here that I've read all over the internet, and if you guys found them and sent them to me. For most systems, CQRS adds risky complexity. It adds to the complexity of the system, and CQRS is significant mental leap for all concerned, developers and project product owners, etc. And few places I've heard that CQRS is seen as a significant force for getting a software system into serious difficulties. So we need to discuss if we want to pursue this at all. But I think that it fits our current approach, so we probably will pursue it. What I have here, yeah, I wanted to show you the architecture on one. If I can copy it. I found this and I wanted to share with you. So this is the architecture for microservices. Microservices can have shared database, but it is not very good to share data between microservices. That's why the next step is that microservices have dedicated database, and they use HTTP calls to call each other. And the other way is to have messaging services between them with event consumer, event publisher. So this will be the base of communication. With this, we are decoupling the producer and consumer. So even if the consumer is down, the publisher will continue working, and eventually the consumer will be back online. And when we add CQRS into all this, as you can see, it gets a lot complicated. We have two microservices here. They have command endpoints and query endpoints. The command endpoints post events in the event store, and also events in the messaging system, which can be read by the other microservice, which can also execute some logic, create some events, etc. And also based on these events, the read storage is updated, so the query endpoint will work. So as you've seen, these are the architectures of microservices used. I won't get into details why. I can maybe share with you here this link so you can read it on your own. Okay, let's continue. Where was I? Yeah, now we are moving to ArkCase next, and this is the simple example of CQRS and event sourcing with just one microservice. When I started thinking how we should implement this, I started with this simple example. And I managed to write this one. Okay. Okay. Yeah, I like to have everything on one screen when I think about things, and that's why it's all cluttered. But I'll try to explain it to you. My first idea, this is with one microservice. We have a dynamic microservice data service, which is responsible to create objects that are dynamic in nature. This means that the objects have their own schema defined with which fields they have and everything, and we have a good way to change the schema in our implementations. And yeah, this service is responsible to write objects and read objects. I will tell you how it will work with a CQRS model. So first, the UI can ask the dynamic data service for this several things. My example here is for the person. It was simple enough for me. So it can get all the persons with dynamic object person endpoint. It can get one person with dynamic object person ID, and then we are going into the CQRS calls. This is a REST call that will create a command for one person. So we have all the person's details that we want to send, and the command UID. This is important because afterwards, based on this UID, the UI will get refreshed. The important thing here is that the dynamic data service can just validate the command if it's correct, and returns to accept it. That does not mean that the person is successfully created, but the command is accepted. The other option that I have here is for the update. Yeah, we can have a command that updates some fields in the person object, but it also sends a version of the objects for concurrency checks, and again a command UID, and will return to as accepted. After the command is accepted, we create the command in Kafka on some topic with commands, and this is the create dynamic object command. It has the person object and the UID. An option here is that the UI can directly create commands in Kafka, and then we validate each command. But I think that some validation before posting the command is good to have in some microservice. Anyway, it's an option. After we create the command, we have a create dynamic object handler. This is again in dynamic data service. This handler will validate the data sent, check for not nuls, validity, and everything, and it can raise two events: dynamic object created or dynamic object creation rejected. If it's if it has some errors, And then I have added here dynamic object updated and dynamic object update rejected for the update options. Anyway, the events still carry this UID. And now, as you can see, the fifth thing is that the UI is this event is sent to the UI via WebSockets, and the UI should refresh the data or show an error message or successful message. I will talk about the UI in a later slide. Here I have written that all commands must have UID generated by the client so they can be matched with the responses. The response here in the UI is quick, and it only means that the command is accepted, not that it finished successfully. And we have the question here how it will handle the eventual consistency and possible exceptions that has happened. That, as I said, is in a further slide, so we won't go in the UI part right now. Important thing here is that we have a command, and based on that command we have few events created, and I have written here, this is the part about the read store. We have some projection of the person with all fields for the read store. This can be a database, Elasticsearch, or whatever we want, even Kafka topic. We have also researched that we can keep objects in Kafka topic. So that's about the read story, and I won't go into that anymore. Then I started to think that most of our calls involve multiple microservices. They don't involve just one of them. For example, when we create a case file, we are involving a data service, we are involving a process service, we are starting a process in activity right now. Then we update Solar, we contact file service to write the file and whatnot. I think that we also have this pipeline context that has all the things that are happening. Anyway, this is again hard to follow in ArkCase as it is now. To enable this in microservices world, we need to introduce a notion of process manager to coordinate all this. Because I will talk about the reasons for this. When we publish event to notify about changes in one microservice, and these events are caught by another microservice, we keep the microservices decoupled from each other. But we have an issue when there is a real logical flow of events. So we need to execute the flow of events in the right order, and this becomes really hard to follow. We cannot. We need to check which service catches each of the events and what it does to understand what's going on. For example, if we have a dynamic data service, a process service, an email service, all reacting to the events, but in the right order. The issue here is that all of the microservices need intimate knowledge of each other. They need to know which events are fired from each of the microservices. So again, this is hard to see the overall logical flow. Another disadvantage that we can have is that when a new business requirement, when we want to implement a new business requirement, It can change the flow and may require change in several microservices. So all this makes it a lot harder. This is why we need to introduce process managers. Process managers have responsibility to coordinate everything, and the three responsibilities that I have written here is that they do event to command transformation. So some dynamic object created event will cause to create a new start process command. The process finished could create send email command, etc. But the good thing here is that all this is centralized in one place, and we can see which command causes which event and the other way around, and it's easier to follow. And we need a change, we just need to change the process manager. So here is that process manager. With the process managers, now we implement the flow as first-class citizens of the main logic, and the overall flow, as well as the logic in each individual step, are part of the domain logic in the context involved. And we can have a state for longer running flows. Some flows can be long running, and it might require some state. So process manager will keep those state. The other way is to pass along this state with each event if we don't have a process manager. So the process manager is, as you can see, is a simple state machine. In rare case, it really needs a state. So in that case, we might need to introduce some other patterns to keep the state. And from what I've read in several places is that frequently an error in implementation is that the process managers are homebrew developed by the team when we have a whole lot of BPMN engines. So in our ArkCase Next application, we have a process service. We started to work on it. It uses Flowable as a BPMN engine. It is a fork of activity, so we have some previous knowledge on it. That's why we went to Flowable. But there are other BPMN engines that can be used and are used frequently. So by using Flowable, this is my this is the idea. It is complicated, but using Flowable, we have the processes defined, and we can see the processes even in the designer. We can change them in the designer, and this makes it easy to follow the whole process, as I said. So I will show you this example here again. So this is again a simplified example. It uses just 2 microservices, but here I have an option for additional microservices. That's why they don't have numbers. So here in this case, the UI can get defined processes from the process service and can start a process, for example, case file workflow. And then it will be a REST call with case file details. The process service will find this process, start the process, and send a command on the on a Kafka topic. Then this command again will be captured by the process service, by the process itself. We can have steps that are executed by listening on Kafka topics, and the next step will execute. The next step is to execute create dynamic object command. So we need to create a case file. This is something for the data service. We need to capture the case file somewhere. And the dynamic data service has create dynamic object handler, similar to the previous example. It will create the object, raise an event, and based on this event, the case file will be projected into the read store. Here I have written it as Kafka. It can be a, as I said, Elasticsearch database or whatever. Anyway, after this dynamic object is created, the next step in the process is, based on this event, is to start the case file workflow as we have it right now. So we have some workflow from the case files. I won't go into them, but it has stages, approvals, and whatever. Anyway, this is a process that is already in activity, and we have moved these processes to Flowable, and they're working there. And this again can start, can raise an event that the case file workflow has started. And this last event might be required by the UI because it wanted to start the case file workflow, and it will react on that, and we know that the case file is saved and the workflow is started. I have added here a few more lines, as you can see. I didn't have space, neither the time to expand on this, but in the meantime, we have some create file command, which creates the case file PDF file. So that can be also inside this process, etc. And we can update the object again using commands and events to coordinate between this. Important thing here is that the process service handles this all, and it can be transparent to the developers and the business users what's happening. And the UI, I have written here that it can get the objects from the dynamic service again, and that works well too. So that's how we can have this working. Let's continue. In this case, we have the commands and events as first-class citizens, and we need to take care of them. These commands and events should be available in the workflow designer, so we don't all still have a workflow designer, but when we do implement it, we can have all the commands and events ready to be chosen by the developer of the workflow. So we can say, okay, this step raises this event or this command, this step continues on this event, etc. So we need to treat them as first-class citizens. And important here is that the commands and events should have their schema, as we have for the dynamic objects and dynamic forms already. So we should also have their schema in the schemas registry. I see that we are at the end of the meeting, so I will try to talk about the UI a bit, and this will be faster. So the idea is that the UI issues a command with UID and receives accepted. And now the question here is how the UI will handle this. We have three options here. First option is the UI if we expect that the command will be successful. We can add the object in the cache and simulate success and show it to the user as it's already successful. Of course, if something bad happens, we need to address that, show something like, oh, sorry, this didn't go well. The other option is for the UI to block and wait for the success or failure event and show the message to the user. And the UI should always update its state based on messages sent by WebSockets. This is something that we partly implement in current ArkCase, at least WebSockets updates, but we need to implement some services to be able to block and wait for an answer, and or adding an object in cache. And this is the, I think, most important thing that I wanted to talk about of the UI. There is a notion of task-based UI. It's more in line with CQRS because every form generates a command representing the intent of the user. It's not as the crude UI we have right now, because we have multiple intentions on one form, and the task-based UI has only one intention. I will show some examples. I won't again go into details to talk about this, but a few examples about task-based UI. One example is this. It's a Windows control panel, and as you can see here, we have intents for users, what the user wants to do. It wants to add a device, add a printer, etc. Not some complicated UI where the user cannot find how to work on it. In our perspective, this is an example that I found. So this is the crude UI when we edit a person or employee here, okay? In one form, we have three intents. We have intent one, modified personal information. The second one is activate or deactivate employee. And the third one is to change the role of the employee. So this is the regular crude UI. In the task-based UI, we should have this with three intents specific, and it should be easier for the user to work with. Any user can relate to this edit personal info, deactivate and change role as separate actions, not opening a big form and finding which value to change. And then we have simpler forms, and these simpler forms create commands which exactly are useful in CQRS. So as you can see, the task-based UI is good. And as the last slide, I will show you the new task form in ArkCase that we have, and we have in this form we have three intents. we create a task with details, with subject, with notes, start date and the due date. Then we have another intent to attach documents, and another intent to assign the task to someone. And this one can be implemented as task-based UI with three forms using next buttons. And this is simple for the user. He doesn't not need to find this upload document buttons to upload a document. So that's about the UI. And thanks for listening in, everyone. So if you have any questions, we can talk now. Go ahead, just jump in.
Hi, this is Sergey. So it's not question. I just think about user experience, because this new approach requires a lot of changes in our current paradigm. So I see that we don't have synchronous response from the server that user expects, and we have notify users about any updates if user interested in these updates. So this command query things I think they don't guarantee response time or something like this. So, and another thing, it's consistency. If we plan to use this approach and we have to use it everywhere. So a lot of questions only
Yes.
as minimum from user experience perspective.
Yes.
So requires more research.
Yeah, you are right. And these are the things that I showed in one of the slides that we need to think about how the UI handles this. These are the options that the UI has in this way. But the good thing here is that we don't always need to wait for the service to respond for something. For example, if we have a task-based UI for the creation of case file, as you know, we create case file in 15 seconds. If we have few tabs, in the first tab we can create the case file. In the second tab we can add files. In the third tab we can do assign participants or whatever we do. I don't really know. And all that buys us time. And the user experience is quite better instead of filling out a form with thousands of fields and waiting for 15 seconds for the forms to respond. On other places, we can have immediate response. We just simulate success. If, let's say, 99% of the time the request is successful, we don't have to wait for a response. We can just add the object in the UI cache. So yes, this requires a lot of UI implementation, let's say, and thinking how the UI will react on different exceptions, etc.
Okay, so, thank you.
The one more thing here. I was thinking about creating case that it takes 15 seconds right now. There are some steps in the case creations that we don't need to wait really, but we do wait for them to finish up to show a case file. So the only step to show a case file is to just save the case details and perhaps add it to Solr search, although it's not really needed. The other steps can be done in the background, like executing rules, saving files, and whatever we do. Those things usually do succeed, and we don't need to wait for a response on those. So with this approach, we can do that in parallel, in background, etc. We just raise 5 events and 5 commands, and in parallel, everything will execute. Yeah.
Sorry, go ahead.
Yeah, this is Vladimir. So, one, I have concern about this task-based UI. So, as I understand, so you're saying that for each entity, we're gonna have multiple forms. For example, instead of one form for creating a case. I don't know how that. So, I will have here problem with dynamic forms and form schemas. So right now we have one schema per entity.
We shouldn't have this. We have an example of task, if you remember, where task rework details is another form. So
yes, but that's part of the process. I'm talking about, for example, creating new entity. Right now we have one schema per.
Well, maybe you didn't understand
okay,
that.
Maybe for updating. Okay.
No, just to tell you this, maybe I was not clear. Creating an entity is itself a process. So we designed this process with the forms included and everything. What is the first form, what it does, what commands it raises, what events it expects, then the second form, etc. So the creating an entity itself is a process. It's not just those business processes that we now have.
And also, if I could step in, it's part of the change in mindset too. When we think about creating an object, we're not thinking about an entity schema. We're talking about what commands are involved. We're thinking about command schema. So what do we need to send to create a case file? We need to send, probably a name, a create date, maybe a subject. What fields do we need to send a command? So like right now, we send the entire case file entity, including the state and whatnot, things that shouldn't be possible to be changed from a regular command object. But then in terms of having a case file details page, then that's part of the query schema. So, we would have kind of a case file query schema that looks more like our case file entity that we have now. But in terms of a command, like we would have a command to change a case file status based on the workflow. There, we shouldn't be sending the entire tremendously large case file entity. We're only sending the case file ID and the new status and maybe some other workflow information. So we should be sending smaller objects on a routine basis instead of tossing around the tremendously large entity objects everywhere.
Yeah. So, yeah, I know, Vladimir, that creating workflows looks scary, maybe, but in this case, it might work just fine. We can see in the workflow what are the forms for creating a case file, what are the commands run, what are the events expected, etc. Instead of having a pipeline manager, we have a real workflow that is running inside BPM engine. And that workflow, when that workflow ends with case file created event, then that's a event that starts the other workflow for the case files, the approval process, and what we have there. I don't remember exactly, but anyway, it's a big workflow that we right now have in ArkCase.
And along those lines, the spring conference that I used to go to every year, this year it's both online and free. It's happening in a few weeks. And so there's a conference on the agenda that talks about service orchestration in exactly the same way that Boyan has described, where there's a state machine that kind of coordinates the work of all the services. And of course, they're talking about using the Spring state machine product and not Flowable, but it's almost exactly the same concept that Boyan has outlined. So I might send out a link to that for whoever's interested in watching it. And also, so Boyan had mentioned that people think of this as being a complex architecture and hard to understand, but the reason that we're going in this direction is that our architecture is neither simple nor hard nor easy to understand at this moment. If you recall the diagrams that Boyan showed, each of the services is only talking to Kafka. There's not lines between a service and some other service, only connections between services and Kafka. So when you're working on the process service, the only thing you have to understand is the code in the process service and the messages it sends and consumes to Kafka. That is not like what we have now. We have over 100 Spring modules, all of which have their own Spring configuration, which is assembled into one tremendously large network of Spring beans, all of which can talk to everything else in there. So all of our all of our probably a couple thousand Spring beans are connected to all the other ones, and it's impossible to understand. So when you're working on the case file service, there's probably a couple of dozen other services that you kind of have to understand to be able to make any changes in. That's why we have some of the issues. We have and that drives a lot of the issues that we have now. So in here, it makes the complexity more obvious, right? You can see it more easily, but each of the services is much more easier to understand in this approach than the architecture that we have now. Okay, we've gone a little bit over time as I expected, so let's take maybe another question or two if anybody has it. And also, I want to state that the set of people that can give these workshops is everybody on this call, or even everybody in our media. It doesn't have to be a member of the core ArkCase team or even the ArkCase leadership team. This is open to everybody. I know that Yasser is working on interesting things. Kamal, of course, knows every interesting thing that's happening in our media. So it's possible to use this workshop time for any topic that you feel is interesting that other people would like to know more about. So with that said, let me open it up again for another question or two, and then we will close up shop. All right. Thank you, Dan. If you are interested in presenting, please send me an email. I will stop recording and we will put the workshop up, and I will get Igor to put it on YouTube, and we will chat again next week. Bye, everybody. And thank you, Boyan. This was a great and very interesting.
Thank you, Boyan.
Yeah. Yes, thank you, Boyan.
Bye.
Bye, everybody.
Thanks. Bye-bye.
Bye.